the product rule. Suppose that we want to find the derivative of two functions that have been multiplied together. One of the things that we need to do is consider the definition of derivative. Turns out we cannot just take the derivative of the first function times the derivative of the second function. The formula is a little more complicated than that. So let's start with the definition. So remember, when we use the limit, we're going to be taking the limit of f of x plus h minus f of x all over h. So if the function that we're considering is f of x times g of x, this gives us the limit as h goes to 0 of f of x plus h times g of x plus h minus f of x times g of x, all divided by h. Now in math, we have something called the creative zero. So we can add something to a function as long as we also subtract it. So in red here, you can see that I've created this nice little creative zero where I'm subtracting minus f of x times g of x plus h plus f of x g of x plus h. These would normally cancel each other out, but I'm putting these in order to get what I need to finish this problem. Now, I'm going to group some things together. I want you to notice the first two terms in the numerator. So here, both of these terms have a g of x plus h. So I'm going to take that g of x plus h and I'm going to factor it out. So if I factor out the g of x plus h from both terms, I'm left with f of x plus h minus f of x over h all times this g of x plus h. So there's the g that I factored out. Now, I can split this up into two different functions here because they both have the same denominator. So I'm going to do something similar with the last two terms. I want you to notice that within the last two terms, they both have an f of x. So I'm going to factor that f of x out to the front, and that leaves me with g of x plus h minus g of x over h. Now, at this point, I want you to think carefully about our definition of derivative. Remember, if we have the limit of two things that are separated by addition, we can take the limit of each piece individually. If you look at the first term we see in our limit, f of x plus h minus f of x over h, that's exactly our definition of derivative for f prime of x. So this term right here is going to turn into f prime of x. Now our second term, if h goes to 0, leaves us with just g of x. Our third term is just f of x, so that can stay the same. And then this last term here is exactly the definition of derivative if our function was g, so g prime of x. So that means when I actually take this limit, I get f prime of x times g of x plus f of x times g prime of x. And it turns out that that is how we calculate the derivative of two functions multiplied together. So that forms what we call the product rule. One of the things I want you to notice about the product rule is that we're using multiplication and addition. Both of these things can be swapped around as we move along, so order is not so important. And what that means is we have two functions multiplied together. We're calling one of them f of x and one of them g of x. And it doesn't actually matter which one you pick to be f of x and which one you pick to be g of x. But the convention is that we pick the first one to be f of x and the second one to be g of x. So let's take a look at how this works. Example 1. Find the derivative of y equals x squared times e to the x. So here we see that we have two functions multiplied together. So since they are multiplied together, I know that I have to use the product rule. So I'm going to do my work on the side because in order to use the product rule, I need to separate out my functions and find each of their derivatives. So the first function I'm going to call f of x, which is x squared, and the second function I'm going to call g of x, which is e to the x. Now I want to find each of their respective derivatives. These derivatives should hopefully be a lot easier than the ones that we started with. So the derivative of x squared is 2x. The derivative of e to the x is e to the x. So now my formula says I'm going to do f prime of x times g of x. So I get 2x times e to the x plus f of x times g prime of x, or x squared times e to the x. So that gives me the derivative of my function. One of the things I want to point out here is that we're calling each of these individual functions f of x and g of x. Sometimes we call the whole function f of x. So in order to avoid confusion, sometimes when we do our side work, instead of using f of x and g of x, we just use f and g, but it still means the same thing. Let's look at another example. Example 2. Find the derivative of y equals ln x times e to the 6x. So again, I see that I have two functions multiplied together, and that tells me that I should be using the product rule. So I'm going to go ahead and I'm going to call the first function f of x, which is my natural log of x, and my second function g of x, which is e to the 6x. Now when I find f prime of x, I can just take the derivative of the natural log, which is 1 over x. But in order to find g prime of x, I need to use a chain rule. So I'm going to go down below and I'm going to say, okay, for an e to something complicated, z is going to be the power of e, which is 6x. And dz dx, the derivative, is 6. And my chain rule said that I'm going to have e to the z, which is the same thing back, times dz dx, so times 6. So I have to use the chain rule to get my g prime of x. But now that I have that, I can plug it into my formula. So I'm going to do f prime times g. So I have 1 over x times e to the 6x from my f prime times g plus f of x times g prime of x. So the natural log of x times e to the 6x times 6. So notice that I have two terms added together. When you do a product rule, you're generally going to have something of this structure where you have two things multiplied together plus another two things multiplied together. Sometimes there's three things if you had to use a chain rule.